Welcome to this lesson on the Distributive Property Part 2. Please make sure you have these notes in front of you so we can begin our lesson. And my students, let's go ahead and update our table of contents. The learning objective for this lesson says I can use the distributive property to write equivalent expressions. So for our key concepts, I want us to think about the area models that we did in our previous lesson. You might have something that looks like this. A times the quantity of B plus C. Notice this problem has parentheses. So when I have my area model, these items need to go on the outside of my model. Notice the A, that is called the GCF. So the GCF always goes on the left-hand side of the model. So if there's parentheses, these items go on the outside of the model. The other type of problem that you might see would be something like this. AB plus AC. Notice this problem does not have any parentheses. So if the problem does not have any parentheses, instead of placing the items on the outside, you place them on the inside. So this would be the AB, and this would be the AC. Notice this does not have a GCF, but that is your job to figure out what the GCF would be. The other thing I want you to think about is the inside of the model always equals the outside of the model. Another thing I want to bring up too is if I have something that looks like this, 17x plus 2, please know that you cannot combine 17x plus 2 to get 19x. That doesn't work. This has an x, this does not, so you cannot combine something that looks different. So let's use these key concepts to discuss the following examples. And now it's time for a quick joke, and this one was told to me by one of my students. Why do you not give Elsa, from Frozen, a balloon? Because she will let it go. For example 1, it says use the distributive property to rewrite 2 times the quantity of x plus 3. So taking a look at the problem, I notice that there are parentheses here, so I know that the numbers in my problem are going to go outside of the model. So the 2, which is the greatest common factor, remember everything that's outside of the parentheses, that's your GCF. The GCF will go here. The length down here, this is going to be called x. This is the plus sign. And the length of the second box is worth 3. So let's go ahead and find the area of the first box. Let's go ahead and multiply 2 times x, and 2 times x gets me 2x. That's the same thing if I was to distribute the 2 to the inside of the parentheses, so 2 times x here would still equal to 2x. Let's go ahead and find the area of the second rectangle. Let's go ahead and multiply, if this side is worth 2, then this side is still worth 2. So 2 times 3, and 2 times 3 gets me 6. So the area of the second model is 6. That's the same thing if I was to go ahead and multiply 2 times 3 here. That would be 6, and since there's a plus sign in between, let's drop down the plus sign. So please know that you cannot combine the 2x plus the 6 because these two terms are different. This term has an x, this term has no x. So you cannot combine them. I can write my final answer like this. 2 times the quantity of x plus 3 is equal to 2x plus 6. Both expressions are equal, even though they look different. The inside of the model is equal to the outside of the model. Example 2 says use the distributive property to rewrite 9 times the quantity of 2x plus 3y. So if I look at this problem, it gives me parentheses, so I know that these numbers should go on the outside of my model. So since 9 is the greatest common factor, let's place the greatest common factor of 9 on the left-hand side of the model. The length of the first box is worth 2x. The little line, let's put a plus sign there. And the length of the second box is worth 3y. So now let's go ahead and find the area of the first box. Let's take 9 times 2x, 9 times 2x becomes 18x. That's the same thing as us doing this. 9 times 2x, using the distributive property, we get 18x. Let's go ahead and multiply the 9 times the 3y to get the area of the second box, which is 27y. That's the same thing as us multiplying 9 times 3y, and that gets us 27y. And because there's a addition sign, let's drop that down. So notice this term has an x, this term has a y. You cannot combine terms that have different variables. So I'm going to rewrite this answer like this. 9 times the quantity of 2x plus 3y is equal to 18x plus 27y. Both of these expressions are equivalent. They look different, but they're both equal. The inside of the model is equal to the outside of the model. So go ahead and pause the video and let's complete these got it problems, and we'll discuss the answers in class tomorrow. Notice I've got 2 got it problems on the slide, got it problem A, got it problem B, and let's make sure we use a model to solve these problems. For example 3, it says factor out the greatest common factor to rewrite 3x plus 15. So this is kind of like the other problem, but it's the reverse, because now they're giving us the inside of the model because there are no parentheses in this problem. So I'm going to write 3x in the first area of the model and 15 in the second area of the model. No parentheses, which means they go inside. Also, please note that you cannot combine 3x and 15 to get 18x. This does not equal 18x, because these are 2 different terms. This has an x, this does not. So you cannot combine things that are different. So let's go ahead and figure out the GCF of 3 and 15. GCF becomes 3. I'm going to write the GCF on the left-hand side of the model. Now our job is to figure out how long the first part of the model is. I'm going to write a plus sign here because the problem has an addition sign, and figure out how long the second part of the model is. So in order to figure out how long one side of this is, let's take the area, which is 3x, and divide it by the greatest common factor of 3. So 3x divided by 3. 3 divided by 3, well, that becomes a 1, and we have an x left over. So that becomes 1x. So think of it this way. 1x times 3 is equal to 3x. So that works. Let's go ahead and figure out the second length, which is 15 divided by 3, which is 5. So this is how you would write the answer. 3x plus 15 is equal to 3 times the quantity of 1x plus 5. If you use the distributive property on this new problem that you figured out, 3 times 1x is 3x. 3 times 5 is 15. So both expressions are equal even though they look different. The inside of the model is equal to the outside of the model. For example 4, it says factor out the greatest common factor to rewrite 27y minus 18. So notice you cannot combine 27y minus 18 because these are 2 different terms. This has a y and this does not have a y, so you can't combine them. But what we can do is we can take these numbers and place them inside of the model because there are no parentheses. No parentheses, let's place them inside the model. So the 27y will go here, and I'm going to place the 18 right here, and I'm going to place the minus sign right on top of the line. So let's go ahead and figure out the greatest common factor of 27 and 18. And the greatest common factor is 9. We can write the greatest common factor on the left-hand side of our model. And our job now is to figure out how long the first part of the model is and how long the second part of the model is. So in order to do that, let's take a look at the area. The inside is worth, of the first rectangle, is worth 27y. So we can take 27y and divide that by the greatest common factor, which is 9. And we know that 27 divided by 9 is 3. But we still have a y left over, so let's go ahead and draw that y right next to it. So the length of this box is 3y. And then let's take 18 divided by 9, and 18 divided by 9 is 2. So we can write our answer like this. 27y minus 18 is equal to 9 times the quantity of 3y minus 2. And this is how you can check if they're equal. 9 times 3y is equal to 27y. 9 times 2 is equal to 18, and there's a subtraction sign right in the middle. So both expressions are equal, even though they look different. So now it's time for a quick comic.
I hate word problems. Are you kidding? Word problems are great.
Go.
Without word problems, math would just be some abstract bunch of formulas that live only within the confines of a classroom or a textbook. But in reality, math is everywhere you look. It permeates everything. You can't escape it, and that's what word problems let us in on.
And that's not a reason to hate them?
And the more math you learn, the more math you see.
So pause the video and complete these guided problems, and we'll discuss the answers in class tomorrow. Notice I've got 2 guided problems, guided problem C, guided problem D, and be sure to show me a model to support your answer. So for example 5, it says factor out the greatest common factor to rewrite 16x plus 4xy. Once again, you cannot combine 16x and 4xy because they're 2 different terms. This has an x, but this has an x and a y. So this one's missing a y, so you cannot combine them. But what we can do is we know that there are no parentheses, and these items can go inside of the model. So this becomes 16x, and on the other side we can write 4xy. Let's figure out the GCF of 16 and 4. The GCF is equal to 4, so I can write the greatest common factor on the left-hand side of the model. So this part is new and different than the previous examples. Notice that both areas inside the boxes have x's. This has an x, this has an x. So that's something else they both have in common. So what we can do is we can take out an x because they both have that in common as well. So now our job is to figure out how long the first part of the box is and how long the second part of the box is. So to do that, let's take 16x and let's divide that by the greatest common factor, which is not just 4, but it's 4x. So let's take a look at this. 16 divided by 4 is equal to 4, but the x is crossed out, so my length is just 4. And then on the other side, we can take 4xy divided by the greatest common factor. So 4xy divided by the greatest common factor, which is 4x. We know that 4 divided by 4 is just 1. And watch the x's go away because they cross out, and the only thing I have left would be a y. So the length of the second model would be 1y. So this is how I would write my answer. 16x plus 4xy is equal to 4x times the quantity of 4 plus 1y. So you can check your work to see how they're equal. 4x times 4 is equal to 16x. 4x times 1y is equal to 4xy. So both expressions are equal even though they look different. The inside of the model is equal to the outside of the model. So pause the video and complete this guided problem, and we'll discuss the answer in class tomorrow. Notice I've got one guided problem on this slide, and be sure to show me a model to support your answer. So now that we've completed this video, go ahead and self-rate yourself and let us know how you feel. If there's any part of this video that you do not understand, please go back and re-watch it. Also come to class with some questions so we can discuss it in further detail.